Hello and welcome to another video. So in this video I'll be going over my solutions for the custom enumerables project in the Ruby path of the Odin project. So when you get there it's going to look a bit like this, and one of the key things that you will have just gone over is how to use blocks and yields, as that will be very valuable in recreating these enumerable methods. So the idea of this project is that we now, in this part of the curriculum, you're very familiar with methods, the Ruby methods and enumerable methods that are available to you for using with arrays and hashes. And the idea here is to put that those blocks and yields to use and rebuild these methods from scratch. And if we look in the enumerable module in Ruby, you can see that it provides methods that are useful to a collection class for querying, fetching, searching, sorting, iterating, and more. And the idea is to recreate these methods. So each with index, select, all, any, none, count, map, and inject, which is also known as reduce. So we're recreating all of these from more or less from scratch, using blocks and yield statements. So the way I approach this, I did it kind of twice, if you like. So the Odin project, the way they provide it is they actually have tests written in our spec for each one of these methods that you create, and so you actually have to write them in a certain way so that these tests can be used. So first time round, just so I knew I was doing things correctly, what I did, I had a bit of a scratch pad here where I was creating standalone methods and then passing in an array as an argument, and then performing something on that array to make sure that the core code block that I was using to recreate each method was working. But in order to actually fulfill the needs of the lesson, I had to go a step further than that and refactor these methods and rewrite them so that they were under these classes. So what we have here is a class array. So we have a class method here that we create, which is the each method, and then that's going to be used in all the subsequent methods, obviously because it is the most versatile one. It's going to each value within an array, and you're going to use that for all the other enumerables as well. But this is defined in a class, and then the rest of the methods are actually defined in an enumerable. And if we were going to take a look at one of the tests here, so this is one of the RSpec tests for myEach, and what they're doing is they're passing in an array here, and then the way they're calling this method is they're actually calling that method on array, on this variable array. They're calling the myEach method, right? And then it's got to pass these tests. So that's how this is being set up and structured. So, in the beginning I did this testing here running standalone, passing in arguments, but to actually pass the Odin project requirements, you're creating it as a class method, which is then going to be called this way instead on this method that they're passing to the test. And to make sure that, so looking at this test to make sure that you are returning self as is required in the Ruby docs. So when you're using the each method, when a block is given, it passes each successive array element to the block and then returns self. So they test for that. So yeah, I'm on the right page here. And they even have notes in here. This should return the original array no matter the contents of the block. Yes, because it should return self. Okay, so that's what this is testing here. And then they define these two empty arrays here and perform a manipulation on the array, and adding the value to these two arrays to make sure that it's also working per what the block stipulates, right? So if, in this case, they're multiplying each element by 2, okay, and then passing it into myEach results, and the same for each results, okay, and then these two should be equal, right? And if they're equal, then your method is working properly. But I just wanted to go through that here just to explain to you why it's got to be written a certain way. and it's to satisfy the use in these tests. And there's obviously a test like this written for each of the methods that you're going to be creating from scratch. Okay, I think the best way to approach this is maybe just show you the original kind of Scratchpad ideas that I had, and then show you the refactored version one by one, rather than going through all of one and then all of the other. So looking at my Scratchpad version here, let's zoom in just a tad. I'm not going to be running these in IRB or anything. I think there's already enough kind of clutter on the screen, so I'll keep it to a minimum and just talk through things. But I just set this array up, or define this variable array here equal to this array of values 1 through 10. And then to recreate the myEach method, I pass in the array as an argument. Okay, and obviously that's different to how you're going to be writing it in the final to pass the tests that the Odin project provides. So what we do here, I have an iterator I is equal to 0, and just using until to loop through, we just say until I is equal to the length of the array, you're going to yield and pass in the value of the I index to yield, right? So obviously we're starting at 0, you're going to be passing in array index 0, you're going to be passing that value to yield, and then we're going to be iterating. So this is getting the core function of passing a value to a block, but this obviously doesn't meet the true characteristics of the each method, because it is not returning self. I just wanted to make sure I was getting down the passing of each value to the block first. So that's what I got here. Oh, that's what I got. So many pages open. That's what I got here. Now, when it was refactored, it looked like this, and down here, when refactored, it looked like this. So this is in class array, and we have the method myEach, and then I actually have a handy method here that's looking for a block, which is very handy when you're working with yield. So if the block is given, then it's going to execute this code, and at the end it's going to return self in the spirit of the each method in Ruby. Same deal, so we just have an I iterator starting at 0, and now we're using self because we're not actually passing in an argument here, we're referring to the object which owns this code here, or is using this code. So until I is equal to the length of self, which happens to be an array, we're going to do this. So we're going to pass the value with the index of I to the block via this yield, and then we're going to add 1 to I, and that's going to continue until I is equal to the length, self.length, and it's going to return self. Okay, and this then does pass those tests that I just described, where they check to make sure that it's returning self and that it is also manipulating the values appropriately with those two new arrays that were created in the tests. Okay, so that once myEach or each is recreated, you're then able to use that in every subsequent method that you're going to create. So the next one is each with index. So myEach with index is very similar. I just have I is set up an iterator equal to 0 using until to loop through. So until I is equal to self.length, do, and then you're going to be yielding the value just like we were in each. But then we're also going to be passing in I, which is equal to the index, as an argument as well, so that the yield block has access to both the value and the index now. It's pretty straightforward, and then we add 1 again to I, so it loops through. So this is my Scratchpad version, and then in the final refactor version it looks a little different but very similar. So again, if block is given, I is equal to 0 until I is equal to the length of self, do the same thing. So pass the value and the index to the yield block, add 1 to I, and then return self. And the reason we're returning self is because that's also what is required in the Ruby enumerable for each with index. So when a block given calls a block with each element and its index and returns self. Okay, and now let's look at select. So if we look at select in the documentation, it says it returns an array containing elements selected by the block. And in the example that they give here, the first one, they pass values 0 through 9 and they call the select method on it. And the block states for each element, you're going to keep the element if element modulus 3 is equal to 0, so it's divisible by 3. That's going to return these values here, 0, 3, 6, 9, right, which are the values that value modulus 3 would equal 0. So let's look at my Scratchpad version here. So in order to set this up, I define an empty array because we need somewhere to contain those values that do return true from the block. We have an iterate I is equal to 0 as usual, and until I is equal to self.length do. So you'll note in these I don't use my each. In each of these blocks I am just running the loop time and time again, but you'll see in the refactor versions I do it differently. But for each iteration we're going to pass to the array the value from the original array if this block or this code returns true. So we're yielding the value to the block. So if the block returns true, then we're passing that value to the array. Right, so you can imagine here that if you, very similar, if you just put the value modulus 2 is equal to 0, or when that returns true, it's going to return true for all of the even numbers in this array, right? And they are going to get passed into the empty array here. And then to return that array, I just put print array, but you don't have to put the print. I was just using it in the terminal there, so it would be visualized. So looking at the refactored version, it's very similar again, but instead of calling the loop for each, I do actually reuse my own each method, which was defined in the array class down below. So what I call here is, again, if a block is given, then you're going to define a new array. And what this block states is for each element in the array, we're going to add that value to the new array if the block that gets passed to this method returns true. And then we're going to return the new array. Else, if there is no block, it's just going to return self. Okay, let's now look at the all enumerable. And this is predicate enumerable, so it's going to return true or false. And it returns whether every element meets a given criteria. It also does return true or false if there is no argument or block. Like for example, if we just call all on 1 through 4, that returns true because they are all truthy. But if we have nil within the array, 1, 2, nil, then it's going to return false because nil is not truthy. However, the way the Odin project set this up, we're only going to be rebuilding this method to accept a block. We're not going to be, it's not tested whether or not it returns truthy or true or false, depending on the actual values contained within. And you can see here, this is the way the test is written. So they pass in this, using this array, we expect your all method to return true if all values are greater than 0, which makes sense. And we'd expect it to return false if all values, if we pass the block, all values are less than 5, which is obviously going to be false. Okay, I just wanted to show you that here just to show you why I structured mine the way I did. I'm just going to go back to my refactored version here. So in my Scratchpad, this is what I have here. So as you can see, I'm not looking to run the all method without a block. I've only really built it here to accept a block. So I just wanted to state that up front. And because it's outputting true or false, it just makes sense to have a variable that is holding that true or false value. And I have this myAll method set to receive an argument, which is an array. And then we're going to iterate through as usual. And we're going to change that result to false if the value passed to the block by a yield is false. So you can imagine if I have my array up the top here, and if I passed in a block saying all values are less than 5, well, that's going to be false because all of these values would return false. Alright, so that's just going to set, as soon as there's one instance that returns false, then that variable here, result, is going to be set to false, and then that kind of captures the intent of this all enumerable, and at the end it just puts the result here to output true or false. And if I look at the refactor version, so again I'm using this if block given method. If it is, then we're going to again set this result default to true, and we're going to use the already built myEach method, and we're going to pass this block to the myEach method, and we're going to say okay, for each element result is equal to false if the value passed into the block by a yield is false. It gets a little confusing here because I have multiple blocks. I basically have a yield within a block which is being passed to another method that's yielding to this block. So you can see how things get a little bit complex. Not really complex, but I just have to think about it for a second. And then at the end we return the result, whether or not it's true or false. Else, if there is no block given, we're just returning self. So you can see how this is where it differs from the actual enumerable here, because it should really return true or false if there is no block given. But that's not how the tests are written, and I'm not sure it was really the intent of this exercise, though it could rewrite it to do so, I guess. Okay, next one is any. And if we were looking in the docs, any looks like this, so it returns whether any element meets a given criteria. So it's kind of the opposite of all, right? So in this case, let's see, one with a block, 1 through 4, any elements less than 2, true because 1 is, 1 through 4, any elements less than 1, no, false because none of them are less than 1. So you can see how that one works. And again, in my scratchpad, I have this variable capturing the output, true or false, but you can see it's the opposite to the all method. Instead, I've set it to false, and then it gets set to true if the value yielded to the block returns true. Okay, and then we output the result to console. And then in the refactor version, right here, again calling if block given, set this variable to false, and then we're using myEach method and passing it this block, and we're saying the same thing. So result is equal to, is true if the yield, the value passed to the yield is also true. Okay, and in Ruby you can write it like this. You can just write if yield, and basically that's the same as if yield is equal to true. Otherwise we return self. Okay, the next one is none. So it returns whether no element meets a given criteria. So let's look at it with a block here. So 1 through 4, none. Element less than 1. So this returns true because none of these elements are less than 1. Does that make sense? 1 through 4, element less than 2 is false because 1 is less than 2. So again, looking at the scratchpad, none here. So I have my defaults this time set to true. We loop through the array, and then we're just saying result is false if the value being yielded to the block is true. Okay, and then we add 1 and we put out the result. And it's going to be very much the same here. So if a block is given, we're going to execute this code, result set to true, using myEach and passing it this block. We're going to say result equal to false if the value passed to the block via yield is true. Otherwise it's going to return self. Okay, now count. Let's look at count. Count's pretty straightforward, but let's look at it anyway. So it returns the count of elements based on an argument or block of criteria. So you could just call it straight up on an array like this, and you're going to have a count of 3. But you could also call a pass a block, and so we can call count on this array here and look for any elements that are less than 2. And as you can see, there are 2 elements here less than 2, and that's the output. So in the scratch pad, so we now have a counter set to 0. We're going to loop through the array, and we're going to say we're going to add 1 to the counter if the value passed to the block via the yield returns true. Okay, now we're going to add 1. And then in the refactor version that gets tested, same deal, looking at if there is a block given, then execute this code, counter set to 0, using myEach, passing it this block. We're going to add 1 to counter if the value passed to a block via yield returns true. Otherwise we're going to return self. Okay, and map. I'm assuming everyone's going to be pretty familiar with map, but it's a very handy enumerable. Sorry if you can hear my son crying, it's bedtime and he gets like this before he has to go to sleep. Okay, returns an array of objects returned by the block. So it's basically a way to create a new array by passing a block to manipulate an array, for example. So I guess an example here would be passing the value 0 through 4 to map where the value is multiplied by itself or squared. Then it would look like this. So 1 would be 1, 2 would be 2 times 2 is 4, 3 would be 3 times 3 is 9, and 4 times 4 is 16. So we've created a new array here based on this block. Okay, so map. In my scratch pad I have an empty array for this, and then we're going to loop through the array that gets passed in as an argument, and we're going to pass to this empty array the value that gets passed to the block via yield. So I think that's pretty straightforward. The same here, if a block is given, then we have this empty array using the already made myEach method, passing it this block, and we're going to pass a value to map array. Sorry, he's getting louder. We're going to pass the value that's passed to the block via yield to the map array, and then we're going to return map array. Else, if there's no block, it just returns self. Okay, and lastly, let's look at the inject enumerable here, which is also known as reduce, and is probably one of the harder methods to get your head around in general, I think, in Ruby or JavaScript when you're using it. At least it was for me anyway, and I think a few others have shared that sentiment. But what it does, it returns an object formed from operands via either a method named by symbol or a block to which each operand is passed. There's some examples here. I'd encourage you to look through the documentation. There's actually a ton of examples of how versatile reduce or inject can be. So for example, if you just pass in 1 through 4 to inject with this plus operator here, it just sums them all together and you get 10. What you can also do is pass in a base value, and then you can also pass in this plus symbol, and then it will add all these values together and you'll get 20. But what that's doing here is it's actually starting off with value 10, and then it's going to go through each value in here that you're passing into it. So it's going to go 10 plus 1 is 11, and then it's going to say 11 plus 2 is 13, and then it's going to say 13 plus 3 is 16, and then 16 plus 4 is 20. So you can see how it starts at a base and then it increments up based on each value that gets passed to it, and then it will return that final value that gets passed to it. So I think that's a handy explanation to go into this. The way I have it written in my scratch pad is not fantastic because it's not accepting a base value. I'm just setting that within the method here, and I would actually have to change that within the method if I was going to pass in a base value. So don't do this, but at least to help me get my head around it, to refactor. So what I'm doing is I have a method that accepts an array, and then we have a base value, which here is equal to 0, but I think it would be much better to have it passed in as an argument with a default value of 0. And then you're going to loop through the array, and what you're going to say is you're going to add to base whatever value is passed in to the block. Right, so you can manipulate those values that get passed in as well. You can multiply them by 2, you can divide them by 2, you can square them, whatever you need to do in that block, and then it's going to return the base value at the end. So in the refactored version here, you can see it does accept an accumulator, right? So the way this is written, an array is going to have the myInject method called on it, but an accumulator can also be passed in, and it has a default value of 0, and then we just set a base in here that's equal to that accumulator, and then we loop through. So in this case I didn't use my each, I just looped through. I can't remember why I did that, but what I'm saying here is base is equal to whatever value gets returned back from, so self I, that's pulling out a value based on the index of wherever this I is at, and it's accepting the base as well in that block, and then we're going to add 1 to here, and that's going to create our loop, and then we're going to return the base value, right? Otherwise, if nothing is passed, we're going to return self. So I'm hoping my prior explanation helps you figure out how this works exactly, but you know, if you pass in nothing as an accumulator, well, the base is going to be equal to 0, and so you're just going to be adding, assuming you have a symbol that you're passing in is add, it's going to be adding each value in the array on to 0. Otherwise, if you do pass in a base value, it's going to be starting from there and adding in each value in the array to that. If you took a quick peek at the tests on this one, let's see what they look like. So it's passing in this array here, and then the first test is it reduces an enumerable to a single value, so it's passing an initial value of 0, calculates the sum of elements of the enumerable array. We'd expect calling myInject method on this array here, passing in an initial value of 0. We're going to take the sum plus value, so we're using plus, which should equal 88, so that would be the sum of all of these. I can also calculate product, starting at 1 as an initial value, so we'd be multiplying all of these values together starting at 1, so I think it'll be 1 times 1 times 1 times 2 times 3 times 5, etc., all the way up. It should equal this number here. And then it also can use it's making sure that the initial value is used on the first iteration. So initial value is set to 100, and in this test it calculates the sum of elements of the enumerable array plus the initial value. So yeah, I mean, in this first one here, the sum of all of these elements was 88, right, because our initial value was 0. Now when our initial value is 100, then the sum should equal 188. Okay, so that's what the tests are doing here, and I hope I did a good enough job to explain how this is working, but it also probably speaks to it's probably the more complex one to get your head around, and perhaps my explanation reflects that a little bit. I'm not sure. Let me know in the comments anyway. Maybe you have a way that explains inject or reduce in a much more succinct way. I'm sure somebody on YouTube has done a far better job than that. But either way, this is a really good exercise, I think, to get you used to writing. Well, it's actually using classes and a module and testing, right? You don't write the tests, but you have to figure out how to write the code so that it will pass the tests. And it's a good practice using blocks and yields and just really getting to know all of these enumerables in Ruby, because if you can recreate them, then obviously you have a really good idea of what exactly they are doing behind the scenes.